Welcome everyone, the professor here. In this video we're going to be looking at value engineering. This is the fourth on our practice topic. This is another topic that is always misapplied. Value engineering is something that should be utilized through the project's life, not just at the end of the design to meet budgetary goals. All value engineering should do just that, create value for the project. After more than 4 decades, I might be considered an elder statesman in this profession. That can come with some very rich experience to draw on. Imagine, few professions have such an extended impact on the world that even after one's death, it continues like this one does. Think about it. As long as a building that you have worked on remains on the face of this planet, a part of you also exists. How deep is that? This should lend itself to a very different view on decisions, more long term. In 1984, the American Institute of Architects, AIA, held its national convention right here in Phoenix. Out of that convention came a profound statement from one of the speakers. Let's look at the screen here. Far too often, you, the architect, against your better judgment, go along with your clients, permit yourselves to be intimidated by developers, builders, and owners who want to make quick profits at the expense of our entire society. Unfortunately, I've come to this conclusion after building for many years and making many mistakes and discovering on my own that the greater the investment in the top line, the greater the results in the bottom line. I think you should have told me this a long time ago. That quote comes from Herman Chanin, president and chairman of the board at that time of Chanin Construction Company, and was published in Architectural Record in June of 1984. Value engineering, if used incorrectly, becomes a cancer for a project. There is no such thing as a limited budget. Mr. Chanin understood that. All resources are scarce, especially funding. That means every dollar we spend has to create some sort of value for that project. In practice, VE has been brought to projects in one of two forms. Throughout the life of the project to increase value, or near the end of design as a means to meet budgetary goals. Either form will impact the budget. However, the first form is the only one that will increase the value to the project. Basic description of what value engineering is. After doing lots of research and everything, I've come to this basic description, if you will. Value engineering is to reduce initial construction costs expressed in terms of value. Now, VE utilized throughout the life of the project will become a very, very powerful tool. I think that's what Herman Chanin was alluding to in his statement. VE utilized at the end of design becomes nothing more than a cancer. It becomes only a scope cut measure, not about bringing value. It is the worst way to reduce the budget, because oftentimes when we make these decisions, we make them quickly. We fail to consider all the ramifications of such a budget cutting measure. And this often impacts other things on the projects. Now, let me tell you a little bit about this because it sounds real harsh, but nevertheless it is true. And I'm going to give you 3 examples here. The first example is a brand new lab building. During the design, budget issues come up, and so the decision was made, you know what, we're going to reduce the size of this emergency generator. An emergency generator is there to pick up essential critical systems in the event that power goes down. Well, the problem was by reducing that, it gave less power to these critical systems that could be put onto that power grid. While moving in occupants in the first weeks after opening the building, it was discovered that there were so many minus 80-degree freezers that have to be on this emergency power circuit that the generator could not support it. So you ended up doing one of two things. You have to either cut what the researchers could bring into the building, or worse yet, you have to go out now and buy a brand new generator on a building that is a few weeks old or a couple months old at the very least. Let's talk about another example. In one project, the roof drains are VE'd out. It's decided that we can cut costs. We're going to get rid of all that piping and everything, and then we'll evacuate the water off the roof through scuppers. Scuppers are a hole in the parapet that just goes out into a downspout, runs down to the face of in the downspout down the face of the building, and dumps out at the base of the building. Problem that they had was no one stopped to think, oh yeah, we have expansive soil underneath our building. Expansive soil, when it gets wet, it swells. What ended up happening years after is all that water sitting at the base started to swell the expansive soil. It started to lift the footings, and we had cracks in the building. So it kind of was another fail. Didn't quite foresee all the future that we have. Example 3, a preschool that's being constructed right now that I just designed. It was built on a very small lot, half-acre site, very, very small. And it was first designed, when we first looked at the design with standard HVAC units, it would have about 15 or more units. Well, the problem with that is that we've taken up a huge amount of the 6,000 square feet required for outdoor play area by the licensing agency of the state. So we started looking at other systems. We decided on a variable refrigerant system, a VRF. It was designed because it would only require 4 small units. It didn't take up much real estate in the playing area, and it met all the conditions for heating and cooling the building. Now, as we got ready to start the construction, the client wanted to go back and look and say, can we cut costs on this? Because the costs were, looked at the time to be kind of high. Well, when we went back and looked at it, the contractor found out that we ended up only saving about $16,000. Well, $16,000, when you look at the cost of operation and all this other stuff, plus all the real estate, was like, you know what, we'd be better off to leave it as. So the decision was to leave this higher hybrid system. Now, these failures in the VE process were realized as the VE process was not respected. It was decided upon late in the ballgame. However, in the successful example, it was done early in the process during early design, not during the latter stages of design, and it actually brought a value that will save the owner money years to come in the future on utilities. There's a successful story. Before using VE, some questions need to be answered, and you have to ask them. And what are those questions? Well, for one, what is the goal of the VE decision? What value is being returned to the project? Some people will call this the value proposition. If you're making a VE decision, it's got to have a value to it. And the best part about it is this value is not only monetary, it's also going to be a qualitative thing. We need to understand that some of these things have to look at long term as well. This is the question that most owners don't like to answer. Was the original budget for the project appropriate? Herman Shannon picked that up. He understood you undercapitalize, you're going to hurt your bottom line in the long run. You're not going to make it as big as it possibly could, thus jeopardizing the success of the project as a whole over its entire life. Will the VE decision possibly cost more in the immediate or distant future to correct? Example, you're moving in these researchers and all of a sudden, hey, guess what? We don't have enough power for the emergency circuits. Now, you can't move in, or worse yet, we've got to get a second generator out there to do it. That's where we have to look at these decisions. How does the VE decision impact the life cycle cost analysis? As I spoke in another video, if you haven't seen it, please go see it. Life cycle costing is an important thing for us to understand. Next thing, will the VE decision hinder initial users' needs? If users are moving in, they can't effectively use the space or the building, all of a sudden you're going to have people grumbling, especially after they just signed leases with moving in expenses and everything. Not going to be very popular with the market that you're trying to serve. Will the VE decision have an impact on the project's pro forma? In the private sector, every project has to do a pro forma. This shows what we are expecting to go through the project, what we put in, how much money we're going to make, how long this all is. Public sector, we don't do that much, and that's probably a failure on that just because of the short-sightedness. But it will have an effect on that pro forma, and we need to consider that. Oftentimes, no one thinks about that. So let's get to some closing thoughts here. 38 years ago, Herman Shannon discovered something and talked about it. That something he discovered was the deadliest decision to any project is undercapitalization. True VE begins at the conception of the project with an appropriate scope of funding appropriate scope to funding ratio. In other words, the scope of work and the amount of funding for it has to be appropriately balanced. If it is not, you're already going to be cutting meat off the bones and not the fat. It also continues throughout the project to the project development to bring continual value in one way or another to the project for the project's entire life. VE decisions must account for a life cycle impacts, immediate user needs, and defer any immediate alterations to the project upon completion. Nothing is more devastating than to just get your C of O, be moving in, and find out we didn't do this right, we're not meeting our needs, and oh crap, we got to build more. I would like to encourage everyone to start thinking of VE, life cycle costing, and deferred maintenance as cogs on the same gear. It is impossible to separate them and maximize the project's success. They have to work in harmony. If you want to read more about value engineering, click on the link below in the description for an article I wrote that has a little more information on it. If you find this video helpful, please be sure to like the video, subscribe to the channel, click on that little bell to receive notifications every time a new video is uploaded. Remember, design well, build safe, and be sure to maintain our buildings to give longer life to them. See you the next time. The Professor out.